Okay, this is starting our linear review, just a little bit that we covered real fast in November and October. So you remember this for your EOC testing. So linear review 22 and 23. You're going to get a printout in class so you can glue this into your spiral. Okay, so our first problem is going to be 2x minus 6y is equal to negative 12. And they want to know if this is a linear or quadratic. The way to know that is look for exponents. This is exponent 1 and 1. That means it's a linear. Quadratic would be a 2. So this is linear. And it says, what is the form of the equation? You had three forms that you were dealing with, and I'll write them up at the top. You had, let's see, we had slope-intercept. Whoops. We had slope-intercept, that was y equals mx plus b. You had point slope, that was y minus y1 equals m parentheses x minus x1. And then you had a standard, that was the ax plus by equals c for your different forms. If I'm looking at this equation, notice the x and the y are on the left side. That means it's referring to this as being the standard form. Okay, they want us to rewrite this form in slope-intercept. So I'm going to take the 2x minus 6y equal to negative 12, and I want to solve it for y, which means I have to move the 2x to the other side. And that drops down 6y is equal to negative 2x minus 12. I'm going to divide by negative 6, and then this all reduces to y equals negative 2 over negative 6 reduces to 1/3, and negative 12 divided by negative 6 is a positive 2. Looking at my equation, this is written in slope-intercept form now, where I have y equals mx plus b. And then on question number 4, it says what is the slope, which is what is m. Remember, this means slope. If I'm looking here, that means my slope is 1/3. And then the b, which is the y-intercept, is the other number, which is 2, or you can write it as a coordinate of 0, 2. Okay. The next one is to fill in a table. Well, there's two ways to do this. I can actually plug in numbers, or I can go to the calculator and type in, go to the y equals and type in 1 divided by 3x plus 2. And then I'm going to go to the table on my calculator right here. So second and table. And I want small numbers because I have a small graph. So I'm going to go up to 0. Oh. And I'm going to look for 3 nice little numbers. So like there's 1, 0, 2. That's a nice coordinate. Okay. I see another one at 3, 3. And looking for another one, there's one at 6, 4. So there's 3 points that I can use on my table. Number, oops, those got backwards. That should be 6 and that should be 7. So I guess my numbers got all off on my paper, so I'll renumber them as I go. It says I want to know the domain and range. Well, remember, your domain were your x values and your range were your y values. And if I was in my calculator, notice I could just scroll and scroll and scroll and scroll and scroll, and this table will never stop in that direction. And if I go in the other direction towards the lower x's, I can go and on and on and on and on and on and on and on, and it will never stop going in the other direction. It just continues on and on and on. So that means that our domain here is going to basically be all real numbers. Their range is also all real numbers. It's not stopping anywhere. Okay, not stopping anywhere at all. On number 7, they want me to actually graph the equation. So I'm going to refer to my table of a 0, 2, then 3, 3, then it has 6, 4. For my graph. Realize I could also use my y-intercept of 0, 2 and my slope 1 over 3, because that means I just go up 1 and over 3, up 1 and over 3. Or I could go back 3 and down 1, back 3 and down 1, and I can draw my line. Remember to draw this with a straight edge. Do not freehand this. So you can use your ID and draw your line. On number 8, they want to know what the x-intercept is, which, remember, an intercept where it crosses the x-axis. And I'll draw those a little larger so you can see them. So this is crossing over here at 1, 2, 3, 4, 5, 6. That would be negative 6 and 0 is actually my x-intercept on this problem. For number 9, they want to know the correlation. Well, correlation ties to my slope. And my option for correlation was that either I have a positive correlation, a negative correlation, no correlation. Well, if I look at my slope and look at my graph, this slope up here was 1/3, which was a positive 1/3. And if I look at my graph, it's going up to the right, so that means this correlation is a positive correlation. On number 10, they said, what is the parent graph? Well, remember, the parent graph is a basic graph, the most basic graph that there is. Well, that means I go back to my equation up here that I had y equals 1/3 x plus 2, and to get the parent graph, I pull away all the numbers. So the 2 goes away and the 1/3 goes away, and all I'm left with is y equals x. That is my parent graph. That is the basic graph of this linear equation. On 11, they want me to graph the parent graph on here. So I'm going to change colors so we can see it. I'll make it red. And the parent graph, remember, is the graph that is a 1, 1, 2, 2, 3, 3 setup for coordinates. So it's like a 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and it goes right on along that particular graph. It must go through the origin. So I'm going to graph this line. Okay. So my red line is actually my parent graph. So you can see that. That's the parent. On 12, they want me to describe the change in the graph. Well, if I'm looking at this, the change in the graph, the parent graph was the original line, and then they started adding things to it. Because on this one, they added a 2 and they stuck the 1/3 on there. So we need to know what these things were doing. If I looked at it, is the line steeper or flatter? So if I'm looking at the parent graph, it was in this direction and then it moved up. So it translates up from this point to that point. It moved up 2 units. And then if I was to actually draw that line right on top of that point and do the same pattern, this line would appear to be on top of my blue line, be up here. So to adjust to the blue line, this thing has to lay down more to fit the slope of the blue line. Okay? Therefore, it's said that this thing is flatter. It's laying down. And then I already answered B. It said the graph translated from the parent graph, it moved up 2 units. Alright. If I look at the next page, or the right hand column, this should be actually question 13. Renumbering my questions real quick. And if I look at it, the equation, oh, I didn't write it. The equation I have for this one is y minus 2 equals negative 1/2 x minus 4. Let me say, okay, is this linear or quadratic? Well, if I look at all my variables, notice I only have exponents of 1s. That means this has to be linear. And I want to know, what form is this? If I look up here at the top, I have three forms: slope intercept, point slope, or standard. And I notice this one's got the parentheses on it with a fraction in front of it. The parentheses equation is the one that has point slope. On 15, they want me to rewrite it in slope intercept form, so they want me to get it where y is by itself. If I take my equation, rewrite it, I want to distribute that negative 1/2 into the parentheses. So that means I get y minus 2 is equal to negative 1/2 x, and negative 1/2 times 4 is a positive 2. I have to add 2. That gives me y equals negative 1/2 x plus 4. Let me write it over here on the side. Okay, here I have y by itself, so this is my slope intercept form. On 16, they want me to identify the slope. Remember, the slope is always with the x, so that means this is negative 1/2. And then the b is the number that's by itself. It's the constant. So that means the b is, I'm going to write it as a coordinate, 0, 4. Now they want me to make a table of at least 3 points. So I'm going to take that equation, I'm going to go to the y equals, clear out what I had, and type in negative 1/2 x plus 4. I'll go to the table, and I am in the wrong neighborhood. I need to get close to zeros, and I want to pick points that I can graph, and I can pick any 3, but I want to make sure I can get it on my graph. So I'm going to say negative 2 and 5. I'm going to do the intercept that I have, 0, 4 right there. I'm skipping the decimal problems, or the decimal answers, and I'm going to do 0, 3. Here the domain, it still continues on and on and on in my tables. It doesn't stop whatsoever, and I can also graph it to see that that's a straight line, and it appears to be going on and on and on and on and on, not stopping. So here the domain, I can say again that it's all real numbers, or there's another way of writing it that you need to be familiar with, and that is the infinity symbol. So I'm going to say it's negative infinity to positive infinity. I put an equals on that one. I should not have. Okay, should be x is, whoops, yeah, it's smeared. But I have negative infinity, x is between negative infinity and positive infinity, and I'll put that on both of these for this example so you see it. And notice the x is in the domain and the range is the y. Okay, on 19 I want to graph the equation, so I'm going to go back to my points and graph negative 2, positive 5, 0, 4, 1, 2, 3, 4, 1, 2, and 3, 1, 2, 3. Okay, I'm going to draw my line. Okay, there's my line. I extended that way out so I could see that point down there on the bottom, because I do need that for 20 where it says I want to know what the x-intercept is. Well, that's right there. I need to know what that coordinate is. So it's 1, 2, 3, 4, 5, 6, 7. 0 is my x-coordinate. Alright, correlation. This is talking about slope again. Remember that. I either have a positive, negative, or no correlation actually taking place. If I look at my line, notice this one is going down in this direction. I can also look up here at slope and notice it has a negative 1/2. So that means this has a negative correlation. Negative correlation. The parent graph, notice this is still a straight line. So if I go up here to my equation and pull the numbers away, all I'm left with is y equals x. So my parent graph is still this y equals x. They want me to graph it, so as before, that's 0, 0, 1, 1, 2, 2 that I'm going to actually graph. Okay, so here's my parent graph that I'm looking at. Now they want me to describe the change. Well, this one's a little difficult because if I'm actually looking at this line, it's going the wrong direction. It makes it a little difficult to see. I can tell how it translates straightforward because I'm looking here. It appears that it goes 1, 2, 3, 4 units up. I can tell that straight out. But to know whether it's steeper or flatter, well, that one is a little bit of a perplexing thing. I can imagine this having the negative parent graph, which would mean it'd be going in the opposite direction of 0, 0, negative 1, 1, negative 2, 2, negative 3, 3, and I can't imagine that one going in this direction. And I'll make this one dotted just so you know that this one actually is not there. Okay, if I was looking at that line being my parent graph and imagined it moving up here to that particular point right there, if I can get my ruler to be straight up and down, which that's not going to happen for that particular setup, then I could see that this line would actually appear to be right up here in this location. That means this line is below the parent graph, therefore it is flatter once again in this particular setup. Okay. Alright, moving on. Going to page 23. This problem gives us a different scenario because they give me negative 5, 4 as a point, and then they actually give me the slope, the negative 3. They want me to write it in point slope form, which remember was y minus y1 equals m times x minus x1, where this was your x1 and this was your y1 and there was your m. If I replace them in my formula, that'd be y minus 4 is equal to the m, which is negative 3. X minus a negative means that turns to a positive 5. That is point slope form. That's it. Now they want me to write it in slope intercept form, which means now I need to distribute the 3 in. So I'm going to write it small here. I'm going to distribute the 3, so that will give me y minus 4 equals negative 3x minus 15. I'm going to add 4 to it. That'll give me y equals negative 3x minus 11. Whoops, almost wrote a 9. Minus 11. There's my equation. They say, okay, is this equation linear or quadratic? Well, if I'm looking at it, this one is linear. They want me to go ahead and write this in standard form. Well, to write this in standard form means I'm going to take the y equals negative 3x minus 11, and I'm going to move the x back over to the other side by adding it. So it'll have 3x plus y equals negative 11, and that's it. I have the x and the y on the left hand side. The a, I don't have any fractions. The a is positive. They want me to fill in my table, so I'm going to go back up here to my slope-intercept, go back to my y equals, clear that one out, and I'm going to type in negative 3x minus 11. I'm going to go to my table. Okay, there was my equation. Go into my table. I want to pick numbers close to the origin. I have 0, 11. That's a long ways away. But if I look here, I have negative 4 and and 1. I want to do negative 3 and negative 2. And then I think I'll do negative 2 and negative 5. Just picking 3. Alright, on number 6, they want to know our domain and range again. And if I think of another way to write this, this could be in set notation. I could put little squigglies of negative infinity, comma, infinity with the little squiggly sign. Those are not parentheses, they're the ellipses actually. This is another way to show all real numbers. 7, I want to graph my point, so I had negative 4 and positive 1. Negative 3 and negative 2 and negative 2 and negative 5. 1, 2, 3, 4, 5. This one is a steep little thing. And find my ruler and draw my line. Okay, so if I'm looking at that, remember my slope was negative 3. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, I got off a little bit for this particular line. Okay. So I have to estimate down here. 1, 2, 3, right 1, and 1, 2, 3, and right 1. Should be way down here for that particular setup. Actually, I know it should be. So what's the x-intercept? Well, it's right there. I need to know what that is. Well, if I'm looking at it, it'd be 1, 2, 3, less than 4. So I'm going to estimate. It looks like it's a little over halfway, but I'm going to pick the middle. 1, 2, 3. So I'm going to say that my x-intercept is negative 3.5 and 0. I'm going to approximate it. I want to know the correlation. I'll look at my graph. Which way is it going? This one appears to be going down. I can also look up here at my slope that they gave me in the very beginning. My slope was negative. The parent graph, if I pull the numbers away from the slope-intercept, all I have is y equals x. And they want me to graph the parent graph. Okay, 0, 0, 1, 1, 2, 2, 3, 3 is my parent graph. Okay. And describe how it changed. So I need to know if this is flatter or steeper for this problem. And then I need to know how it translates. If I look at my translation, this starts at the origin, but this time it goes down, and I need a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it should be 11 down. If it goes off your graph, remember the distances traveled is the y-intercept. Now it is sitting right there on your problem of how much it translates. This one went down 11. On your other graphs, your y-intercept was 2. It was a positive 2, so that means it went up 2. On this example here, you had a positive 4, so that means this went up. This one is a negative 11, so it goes down 11 for that problem. Okay, now we need to know whether it's steeper or flatter. Well, if I imagine this line being flipped the other way, let me change colors so we can see it flip the other way. This line will be going right through here. Okay, that represents my parent graph, just the negative going the other way. It makes a big X. If I imagine this line sliding down to the y equals down here, making sure it's parallel, just bringing it on down to that negative 11 down here. Notice your graph, the new graph, is above it this time. Okay, it's this way. Okay, it's above the line. When it's above the line, that means it is steeper. And realize it's steeper because the slope is above 1. It's a 3. Now I'm ignoring the negative because the negative just tells you which way the graph is correlating. But if I look at the slope of the whole number is a 3, it's above 1, therefore that's why it is a steeper slope. Alright, last example, last type of way you solve these equations. If I give you the coordinates okay, 2, 3, and then I also give you 3, 8. I give you 2 points. First thing I need to do is find slope. Remember, slope, the formula was y2 minus y1 over x2 minus x1, where these were x1 and y1, x2 and y2. So to find my slope, I'm going to plug it in and see that this is going to be 8 minus 3 over 3 minus 2, which gives you 5 over 1. That means my slope is 5. Now they want me to write it in point slope form, so I get to pick one of these points, and I'm going to pick the first one here and fill in my point slope formula, which will be y. Remember that formula is y minus y1 equals m parentheses x minus x1. So that means I'm going to have y minus 3 is equal to 5 times x minus 2. They want me to write it in standard form, so I'm going to distribute. Let me rewrite it here. I'm going to distribute this in and come out with y minus 3 is equal to 5x minus 10. I'm going to add 3. That gives me y is equal to 5x minus 7. And this is my slope-intercept form. Okay. To get it in standard, I'm now going to move the 5 to the front by subtracting. And I'm going to go ahead and write it down this side because that means I have negative 5x plus y is equal to negative 7. That's almost correct, but I cannot lead with a negative, so I have to go through and multiply everything by negative 1. Negative 1 times negative 5 turns that to a 5. Negative 1 times y is a minus 1y. And negative 1 times negative 7 is a positive 7. This is my standard equation. They want to know what the y-intercept is. Well, y-intercept is negative 7. It's right there on your graph. What would I fill in the table? So I'm going to type that in my calculator. Clear that out. I'm going to put in 5x minus 7. I'm going to go to the table and I want to pick the small numbers. I think I might be able to get 7. 1, 2, 3, 4, 5, 6, 7. 7's on the very bottom, so I'm going to do 0, negative 7, 1, negative 2, and 2, 3. Okay. Alright, my domain and range I'm going to say is all real numbers. And then I want to graph it. 0, negative 7. Okay, this has a steep graph. 1, 2, 3, 4, 5, and 1. 2, 3, 4, 5, and 1. 1, 2, 3, 4, 5, and 1. So that is has a big step for that graph. Let's know what the y or the x-intercept is, which it appears to be right there is my x-intercept, which it looks like it's about 1.5 and 0. Correlation, if I look at my slope, notice the slope is positive. That means this is a positive correlation. The parent graph is y equals x, and I want to graph that equation. Remember, that is the equal points 0, 0, 1, 1, 2, 2, 3, 3, all the way. And then I need to get to describe the change. The translation, it intersects the y-axis down at the bottom, so from 0 to the y-axis it should drop 7. I can count it. 1, 2, 3, 4, 5, 6, 7. 7 units down. And now I need to know whether it's steeper or flatter. So if I'm looking at my slope, the slope on this one was a 5. If I slide this graph down, if I keep it parallel but slide it down, notice it is above, because I have to compare the y-intercept. So that means from here it'd be going just like that, would be my parent graph, and you notice it is above. Okay, that means it is steeper. And realize here the slope of the parent graph is 1. Our equation, we're looking at the slopes, and you see how the new slope is above. This one was the parent slope, and this is the slope of your equation. This is a greater than 1, that's why it is steeper. Alright, that completes our notes for linear functions. This was a fast review over all of the types of problems we've had so far. I have glued this into my spiral, so you need to do the same. Thank you.